Hello everyone, I am Viral and welcome to another session of The Boring Teacher. Let us try multiplying numbers using the Japanese trick. Okay, suppose if I have a number, let us say 21, when multiplied by 23, we are taking a random number. Okay, the first number is 21, so we'll draw two lines like this, 1, 2, and leaving some space, one line like this represents 21, right? Two lines for this and one line for the other number. Okay, similarly the other number is 23, so we will draw 1, 2 lines like this and 1, 2, 3 lines like this. I need to extend the other two lines because they are not intersecting. Fine, now they are intersecting. Okay, now these lines you have to divide it into three different groups. One group is this, the second group is this, and the third group is this. Okay, now you have to count at how many different points the lines are intersecting in each different zones or each different groups. Okay, let us look at the first one. Let us count. It is intersecting at 1, 2, and 3 different points. So I'll write a 3 over here. Let us see, for the second zone it is intersecting for 1, 2, 3, 4, 5, 6, 7 and 8 times. So I'll write an 8 over here. Let us look at the zone 3. 1, 2, 3, 4. There are 4 intersections. So the multiplication, the answer of this 21 when multiplied by 23 would be equal to 483. Try it out. Verify for yourself. Now let us take some other number and try multiplying again. Let us see if it gives us a correct answer. We take suppose 31 multiplied by 33. Okay, the first number is 31, so 1, 2, 3 lines like this, leaving some space, the other line like this. The second number is 33, so 1, 2, 3, and 1, 2, 3 lines like this. Now again we will divide this into 3 zones, 1, the second zone, and the third zone. Okay, let us count how many intersections are there. 1, 2, and 3. For the second zone, let us see how many intersections are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so there are 12. Now whenever we get a 2-digit number here, the second digit stays there, the first digit is transferred to the next zone. Okay, so 1 will be added to whatever number comes in the third zone. Well, now let us count the number of intersections for the third zone. 1, 2, 3, color changed, 3, 4, 5, 6, 7, 8, 9. So 9, 1 plus 9, that will be equal to 10. So our final answer for this multiplication, 31 multiplied by 33, will be 1023. Try it out. Let us try with a 3-digit number. Let us see if this still holds true. Let's multiply 321 with, let us say, 13. Okay, the first number is 321, so 1, 2, 3, leaving some space. The other number 1, 2, leaving some space. The third number, and for the second number 1, 3, one line like this, 1, 2, and 3 like this. Okay, now let us see what do we have here. Now this is divided into 1, 2, 3, and 4 different zones. Let us see how many points of intersection can we get. Okay, 1, 2, 3. For the second zone we have 1, 2, 3, 4, 5, 6, and 7. For the third zone, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is a 2-digit number, so the second digit stays. The first digit is transferred to the next zone. So 1, 1 plus 1, 2, 3. 1 plus 3, we will get 4. So I'm writing directly 4 over here. So the answer of this multiplication, 321 multiplied by 13, will give me 4173. Isn't it correct? So this is it for today. If you have enjoyed the video, then do not forget to like the video, share the video, and if you are new to the channel, if you are attending the session for the first time, do not forget to subscribe. I'll see you in the next one.